Hi everyone, this is Mr. West. We're doing the Properties of Exponents Challenge, integer exponents exercise in Khan Academy today. Should be a good one. Let's check it out. Which expressions are equivalent to 5 to the 12th power times 5 to the 8th power? Okay, so this is essentially a Properties of Exponents review. We have here two like bases, so 5 and 5. Okay, and they're both being raised to different powers. This one's being raised to the 12th. This one's being raised to the 8th power. What does this mean? So quick review of exponents. This just means 5 times itself 12 times. So we can write this out 12 times 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, a little excessive, but that's what it is. I'm going to have to write this to the left. So this is times itself 8 times. So we're doing 5 to the 12th, written here, times 5 to the 8th. So 5 times itself, 8 times. 1, 2, 3, 4, 5, 6, 7. And I'm going to put it over here, 8. Okay, sorry about that, but I mean, it's all the same. Now, what does that mean? That means we can have 5 times itself how many times? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 5 to the 20th power. That's what it's equal to, okay? And that goes along with our law of exponents, that if we have like bases, we can add the exponents. So it's essentially the same as 12 plus 8, 5 to the 20th power, okay? You probably already knew that if you're taking this challenge, but I just wanted to show another way to go about it. Okay, so we just have to find which one of these is equivalent. We have to choose 2 answers. Now, it's not writing it like this, so we have to see, okay, which one of these is equivalent to it. So this is actually a really good exercise. I will probably assign this in the future. Now, sorry, I did this without talking. Here, 25 to the 20th. Well, if it's 5 to the 20th, there's no way that 25 to the 20th is equivalent to that because it's a different base to the same power, so that's incorrect. Here we have a power raised to a power. Anytime you have power raised to a power, you multiply the exponents. This is 25 to the 20th. That's the same thing. B is not the answer. Okay, we already said that if we have like bases, 5 and 5, we can add the exponents. So 5 to the 3 plus 2, don't forget parentheses, to the 4th. That's 5 to the 5th power to the 4th power. And that's the same as both of these, so this is going to be our answer. But why? Power raised to a power, multiply exponents, 5 to the 20th, 5 to the 20th, C, D, done. Okay, I'm going to go probably a little bit quicker from here on out. Which expressions are equivalent to 1 over 5 times 1 over 5 times 1 over 5 times 1 over 5. I was trying to say 1 over 5 and 1/5 at the same time, for the record. Now, 1 over 5. That's the same thing as a negative exponent. 5 to the negative first power. That's equal to 1 over 5 to the first power. Just in the same way that 5 to the negative 3 is the same thing as 1 over 5 to the third power, or 1 over 125. Okay? So that's what the principle of negative exponent is. Keep in mind that we have this exponent times itself 4 times. So we already said that 1 over 5 is equal to 5 to the negative first power. And we're multiplying it by itself 4 times. So that's the same thing as 5 to the negative 4th power. Okay, so we just need to look for any expression that's equal to 5 to the negative 4th power. Let's look at the first one. 5 to the negative 2 times, or to the second power. Power raised to a power, we multiply exponents, that's 5 to the negative 4. A is going to be one of our answers. B looks like a tempting one, okay? We have 5 to the negative 4 raised to the 0 power. Power raised to power, multiply exponents, we get 5 to the 0. But anything raised to that 0 power is going to be 1. That's one of our exponent rules. X to the 0 is 1. 100 to the 0 power is 1. Negative 125 to the 0 power is 1. Okay, so anything to the 0 power is 1. Here we have 5 to the first over 5 to the 4th. Okay, this is also a tempting looking one. So we have 5 over 5 to the 4th. Okay, if we have division, what we're doing is we're subtracting exponents. So really this is 5 to the 1 minus 4. 5 to the negative 3, not the same thing. So if we're choosing 2 answers, we know it's D. Why is it D? Like bases, add exponents. 2 plus the negative 6 is plus the negative 6. Add exponents when you multiply, 5 to the negative 4. So A and D for our answers this time. Okay. Which one of these is equivalent? We have 2 to the 5th power and 6 to the 5th power. Well, what we can do here, this is one of our exponent rules, is we can rewrite this because it's raised to the same power. We can rewrite it like that. Why is that useful? Because now we can simplify this. We can simplify it by saying that this is equal to 1/3 to the 5th. I divide the top by 2 and I divide the bottom by 2. And it's equal to 1/3. Why can we do this? Well, this is the same thing as 2 to the 6 raised to the 5th power, which is 2 over 6 times 2 over 6, which we can reduce each one to 1 over 3. I did it again. Boy, can't shake off that lesson from last time. Okay, so anyway, I have 1 over 3 to the 5th power. That's 1/3 times itself 3 times, so it's not going to be A. Did I say 3 times? I meant 5 times. Okay. It could be B. And why could it be B? Because we can rewrite 1/3 as 3 to the negative 1st power. And then if we're raising that to the 5th power, that becomes 3 to the negative 5th. B is going to be our answer. Okay, this one's not even close. It's a different base and everything. I don't think... No, that cannot be the right answer. So it's got to be D, but why is it D? Well, we have 2 times 6 to the negative 5th power. Well, the first thing I'm going to do here is 2 to the 5th. I'm going to change this so that it has a positive exponent by moving it into the denominator. That's what you can do. This is equal to 1 over 6 to the 5th power. So if you do 2 to the 5th times 1 over 6 to the 5th, this is what you get, and that's what we started with. So B and D are our answers this time. Next question. All right, here we go. Natalie, try to evaluate the expression 4 to the negative 3rd times 2 to the negative 3rd to the 0 power. All right, we already know the answer. Okay, so we already know anything raised to the 0 power is equal to 1, and we see that she got 0, so we know she messed up somewhere, but where? Okay. Did Natalie make a mistake? If so, which step? So let's see. We have 4 to the negative 3rd times 2 to the negative 3rd, and she said that that was 8 to the negative 3rd power. That's wrong. So she already messed up in step 1. Can we choose more than one answer? Well, she messed up in more than one spot because we can rewrite this as 1 over 4 to the 3rd times 1 over 2 to the 3rd to the 0 power. Okay, so that's the same thing. I kind of want to go back and take a look at the other one, but I believe you can't multiply these bases and just keep the numerator the same. That's not how it works. So let's just double check here. We can check, and let's see, times, that's 64, and then that's, okay, well, actually, so check this out. Because this is, they're both raised to the 3rd power, we can put this, sorry, let me go back. 1 over 4 times 1 is half, and we can put it like this. Because they're both raised to the 3rd power, we can take out that exponent. So now it becomes 1 over 8 to that 3rd power, which is the same thing as 8 to the negative 3rd. So she's actually good in step 1. I got a little too excited here, and that is actually correct. That's the rule of exponents applies to that one. But we have 8 to the 0. That's good also because we have a power raised to power multiply. But 8 to the 0 is not 0, it's 1, as we talked about right from the very beginning. So for this last one, step 3, she done goofed. All right, there we go. Almost made a mistake. So Natalie made the mistake, not us. So hopefully you follow along, and I hope you enjoyed this video. Make sure to check out more videos. Leave a comment if you need help with any other concept, and I'd be happy to make a video for you. And I look forward to seeing you next time right here on West Explains Best.